This is the screencast for section 5.4, example 5. So the first part of the fundamental theorem of calculus dealt with when one of your limits is a variable, upper or lower limit of integration, the other one is a constant. Now we're going to move into what if both are constants. So the fundamental theorem of calculus part 2 says that the antiderivative from a to b, constant a to constant b, is of f of x dx, is the antiderivative of your integrand evaluated at b minus the antiderivative of your integrand evaluated at a. So kind of a picture for that. So say this is f of x. We're going to take the area under the curve, so the antiderivative, up to b, and cut out the area under the curve up to a, the antiderivative of a. Now the proof for that is on the next page. So if we look at the proof for the fundamental theorem of calculus part 2, we're actually going to use the fundamental theorem part 1 in it. So we start out and have this expression g of x, capital G, which is the antiderivative of little f. So any antiderivative of f then is called capital F, which is going to be g plus a constant. So, take the antiderivative and you'll find that function g plus a constant. So now we're going to start out actually at the end of our proof and work our way back to the beginning. So we're going to start out with just assuming capital F of b minus capital F of a. We're going to start out with this expression. So we've got this capital F of b minus capital F of a. So now by this definition, capital F of b is capital G of b plus a constant minus, and then capital F of a is capital G of a plus a constant. So those constants would cancel out, much like we've seen in the past. And we have now capital G of b minus capital G of a. Well, by the definition here, capital G of b is the antiderivative from a to b of f of t. And then here, the capital G of a is the antiderivative from a to a of f of t. So now, the antiderivative from a to a is 0. So now we just have the antiderivative from a to b of f of t dt, which was the expression we were looking for. So, final answer, f of b minus f of a is actually the antiderivative from a to b of f of t dt, just because we worked backwards from the expression using the antiderivative. And the fundamental theorem of calculus part 1, in that the antiderivative from a to a variable is, we can call it capital G of x. We can come up with that expression. So looking at how that's applied, example 5, let's evaluate this antiderivative. So first of all, we have the integrand x cubed plus 1, and you know how to take the antiderivative of that. That would be, let's see, I'm going to add 1 to the exponent, so now x to the 4th. Now I'm going to divide by that new exponent, so 1/4 x to the 4th, plus the antiderivative of 1 is x. Now technically we do have a plus c, but as you saw in the proof here, our plus c's would cancel out once we plug in the two constants. So we don't need to worry about that when our upper and lower limits are both constants, just like we didn't have to worry about it when one of them was a variable as well. And we're going to evaluate that, shown by this notation, from -1 to 3. So I'm going to first plug in the upper limit, so 1/4 times 3 to the 4th plus 3, and then minus the plugging in the lower limit, so that would be 1/4 times -1 to the 4th plus -1, and overall I get my final answer of 24. The now try problem number 29 asks us to do the same thing. I am going to check this using my calculator at the end, which I already did, so I know my answer should be about 1. Okay, so let's rewrite this antiderivative as something I can easily take the antiderivative of, so that would be x to the 1/2 instead of that square root of x. Now the antiderivative of x squared plus 1/2 x is 1/3 x cubed, plus adding 1 to the exponent 1/2 is 3/2, so that'd be 2/3 x to the 3/2, and that's getting evaluated from 0 to 1. So I'm going to plug in 1 first, the upper limit of integration, and subtract, plugging in the lower limit, and I do get 1. So my calculator and my calculus on paper line up. I think I have the right answer.